Bailey. I'm a professor at Colorado State University here in Fort Collins, Colorado. I'm in the Department of Environmental and Radiological Health Sciences, and I teach radiation biology. So radiation is an interesting thing. It can be used to treat cancer, so high doses of radiation treat cancer, so we're very interested in, for example, radiation oncology applications and how we can use radiation to kill cancer. On the other side of things, which is where I'm really more involved, is how low doses of radiation can cause cancer. So there's a lot of applications for that, or scenarios. Like around here we worry about radon, for example, causing lung cancer. I had always had an interest in biology, so that's what I got my bachelor's degree here at CSU, actually, many years ago. And that's really what started me on the path, because after I finished my degree, I needed a job. I mean, that was, primary. So I went to my advisor for the first time after I was all done and, asked him if he knew of any jobs. And there was a new professor on campus who was in the radiation biology department at that time, and the department was just getting started and building. So it was something that, I'd never even heard of before. After about 5 years, we did move back to New Mexico because babies started coming along, and we had 3 children. And I made the decision at that point to stay home with my kids and raise them. So there was about a 10-year period there where I was at home raising kids and selling Tupperware and just, again, not really knowing, but very slowly but surely made it through a master's and then eventually a PhD about the same year that my youngest graduated from high school. So, we all finished school at the same time, and then I was recruited back here to CSU, and I've been here since 2001. The research I do, contributes to the NASA mission and really the future of human spaceflight, as well as to people on Earth. That's another very important aspect of the things that go on with NASA. Is they want to be sure it has some kind of impact for us mere Earthlings as well. I try to put our work into that perspective. Certainly, we all worry about getting older, aging, getting cancer, getting cardiovascular disease. So any of the things that we discover about factors that influence how quickly all of that happens, how quickly our telomeres shorten, how we can prevent that, it's going to benefit all of us on Earth as well. There are some very different kinds of radiations that the astronauts are exposed to in space during spaceflight. Even in the ISS, so the International Space Station is in what they call low Earth orbit. So it still has some protection from the Earth's magnetosphere, but it's still, they still are getting exposed to things that we don't get exposed to down here on the surface because of the atmosphere and the magnetosphere. So things like X-rays and gamma rays. But in space, they actually get exposed to many more protons, like from the sun, as well as particles that just are like bowling balls, going through our cells and damaging DNA. So the NASA twin study was actually initiated on the suggestion of Scott Kelly himself. So Scott was selected for the 1-year mission, the first 1-year mission that NASA had done on board the International Space Station. And during a press conference, he asked the question of whether or not NASA was doing anything because he had an identical twin brother, Mark Kelly, who had also been an astronaut. They decided very quickly that they really should. It was a very unique opportunity to be able to look at health effects in genetically similar individuals who also had similar lifestyles, in that they'd both been Navy test pilots, they'd both been astronauts. And NASA then put out a call for studies that would look at health effects in Mark and Scott. And we were fortunate enough to be selected as one of the 10 investigations that studied Mark and Scott all the way through. So before the flight, before the 1-year mission, during the mission, and then after, out 9 months after the mission, we had samples. I think the most unusual thing, or the most surprising finding that we had, was that there was a very space flight specific elongation of telomeres. Because telomeres are they're the ends of our chromosomes, and they shorten as we get older. As we age with cell division, they shorten with stress, all kinds of different stresses. So that was completely against the hypothesis that we thought all the stresses of space flight and the radiation exposure would all really accelerate telomere loss, so we would age more rapidly. And that was our hypothesis, that space flight certainly would be something that would accelerate telomere loss. But in fact, it did exactly the opposite. They got longer, and we have no idea why that is. It's humbling to be a part of NASA. I mean, it's exciting and it's humbling, and it's an honor, honestly, because it does have an impact globally and to the whole future of mankind. If we think of as space as the next frontier, perhaps not the final frontier, but the next frontier. And it's also amazing to watch how NASA works. And once you start to appreciate how much the engineering, how the spacecraft itself, and how that thing can even fly and be in orbit around the Earth is an amazing feat. All of the engineers, all of the mission control, all of these pieces, and the people, they're just kind of in this box, in this machine, and somehow we have to keep the people safe and healthy. And what kind of consequences are there going to be for them, health-wise in the long run, is our little bitty piece of that. But it's a very important piece, and I certainly do appreciate what a privilege it is to be a part of that.